Thank you guys for joining me today. In this video, I will go through the effect of temperature on the composite column. Before starting, I would like to highlight a point. If we have a member from material number 1 is supported from one end and free from the other end. We have another material with the same length, but material number 2. Both of them under the effect of a change of the same temperature. Which material will expand more than the other material? Keep in your mind the expansion due to temperature equal alpha delta T time L. Since the two material or the two members has the same length, the two members under the effect of the same change of temperature, so the only factor that will control which one will elongate longer than the other one is alpha. So assume the alpha of this material, alpha 1 equal, for example, 5 times 10 to power negative 6. And the alpha 2 equal 10 times 10 to power negative 6. So which one will elongate longer? The material number 2. Does that make sense? So under the same change of temperature with the same length, which material will expand, will elongate more? The material with the higher value of the thermal expansion coefficient. Does that make sense? The same here. I'm gonna use a technique to solve the composite column under the effect of temperature. But before starting, I would like to highlight the alpha for steel equal 17 times 10 to power negative 6. And the alpha, the thermal coefficient of expansion for concrete equal 11. That means the steel will expand more than the concrete under the same condition, the same temperature, the same length, everything the same. So this composite column will be solved like this. We have concrete and we have steel. Originally, both of them with the same length. So this one is steel and this one is concrete. So I will assume first, assume free expansion. So concrete will expand alpha concrete delta T L concrete. So concrete will expand a little bit. How much? Delta concrete. And this free expansion for concrete will equal alpha of concrete, change of temperature, time length of concrete. And the length of concrete is this one, which equal the length of steel also, by the way. Also, the steel will expand with the free amount, alpha steel, delta T, L steel. So the steel will expand more than the concrete. And we figured out why. Because the alpha of steel is bigger than the alpha of concrete. This is the expansion of steel. Unfortunately, we will have a difference. Delta. This delta difference between the expansion of steel and the expansion of concrete will equal the free expansion of steel minus the free expansion of concrete. So I can figure it out. But this difference will not happen because the concrete and the steel are one unit. Yes, they are two materials, but they are working as one unit. So what will happen? What will happen? We will have a force trying to push the steel down, and another force, which is the same force, trying to push the concrete up. So both of them will be here. So second one, we will have a force P trying to push the steel down. How much? Plae. Plae for steel. And the same force P, the same force, because summation F of I equals 0. So P and P will pull the concrete up by PLAE for steel. Keep in your mind, this force P is the same like this force P, but the rest, this one for steel and this one for concrete. So the amount that steel will push down and the amount that concrete will pull up, if you add them together, P, L steel, A steel divided by E steel, plus P, L concrete, I'm sorry, this one is concrete, divided by plus E concrete, both of them, if you add both of them, must equal the original difference between the two levels, concrete and steel, which is delta different. From this equation, I can find out the force P. Once you get the force P, I can figure out the stress in steel equal the applied force divided by area steel, and the stress in concrete will be the applied force divided by area concrete. This one will be tension, this one will be compression. Why? Do you remember? I told you I will assume a force P trying to push the steel down. So the steel will be under compression for this force. And the same force P trying to pull the concrete up. So it will apply tension. So it will be tensile stress. That makes sense? So I can figure out the stresses in steel and the concrete due to the temperature. Anybody can tell me what will be the final elongation in the composite column? Keep in your mind, the original of the composite column was here. The final became here. So what will be the final elongation in the composite column? This final elongation will equal the total free elongation of the steel, delta steel, minus the PLEA of the steel due to the effect of the force P. So the final elongation in the composite column will equal the original elongation in steel, which was free, which you equal alpha delta TLS, minus the amount that the steel returned back due to the effect of P. So minus P L steel divided by area steel E steel, or equal the free elongation of concrete plus the amount of elongation of concrete due to the applied force P. So delta concrete plus PL concrete, area concrete, E concrete. Does that make sense? I would like to highlight this point one more time before starting to solve an example. This is the concrete. This is concrete. And we have another material is steel. Both of them originally was here, and both of them has the same length, L concrete equal L steel. We have a change of temperature, so I'm gonna assume each one will expand freely. So this is the expansion of concrete. How much? Delta concrete equal alpha concrete delta T L concrete. And the steel will expand freely. How much? Delta steel equal alpha steel delta T L steel. So we will have difference in between. We will have difference in between the two material. This difference equal delta steel minus delta concrete. So I can figure it out. This is the difference. We will not expect this difference. This is just assumption. I assume the steel can expand freely and the steel can expand freely. But this is not the case. So both of them will move together and cannot leave each other. They are working with one unit. So I will assume this level of steel will be pushed down. And this level of concrete will be will be pulled up. So the two material can reach to work together again. The amount of contraction in steel equal the applied force P, L steel divided by A steel, E steel. The amount of concrete that pulled up, P, L concrete, area concrete, E concrete. Keep in your mind, this amount plus this amount equal the original difference between the two materials, which is here. And keep in your mind, the applied force P, I assumed it, P trying to push the steel down, so it will cause compression to steel. And the same force B trying to pull the concrete up, so it will cause tension in the concrete. And this is the reason why during fire, concrete will crack. Because during the fire, the applied force in the from the fire on the concrete will pull it to expand with the same amount like steel. So we should expect tension and the tensile stress and subsequently cracks in the concrete. We have an example. This composite column made from concrete and steel. Alpha steel is given, alpha concrete is given, and we have a change of temperature 50 Celsius. And the E steel and the E concrete Young's modulus. We need to figure out what are the normal stresses developed in concrete and steel and what is the final change in the length of the composite column. So we need to be careful. So I will start to solve this problem by saying this. I have concrete inside. This is the concrete of the composite column. And I have steel outside. This is steel. Both of them has the same length. L concrete equal L steel equal 400 millimeter. That makes sense? So the first step, I will assume free expansion for the two material. Each material is expand alone freely. So the concrete will expand a little bit by delta concrete. This delta concrete equal alpha concrete delta T length of concrete. Alpha concrete is given 11 times 10 to power negative 6 time change of temperature 50 time length of concrete 400 millimeter. I think this 400 is too small. It should be 4,000. 4,000. The total length of this column is not 400, it's 4,000 millimeters. That makes sense. So 4,000 millimeter. So the total free expansion of concrete will be 2.2 millimeter. I will assume also the steel will expand freely. So the steel will expand more. How much? Delta steel. This delta steel equal alpha steel delta T time L steel. Alpha of steel 17 times 10 to power negative 6 times 50 times the same length 4,000 millimeter. It will be 3.4 millimeter. So we will have difference between the two expansions. This difference will equal 3.4 millimeter minus 2.2 millimeter will equal 1.2 millimeter. That makes sense? This difference will not happen. This difference will not happen. So we need to move the level of the steel down after a force P. The same force P will try to to pull the concrete up because the steel cannot go the whole down, the whole difference. So I will ask the steel to move down a little bit and ask the concrete to move up a little bit so the two material can reach to each other at this level. Does that make sense? So the steel will move down this amount. How much? P time L steel divided by area steel E steel. And the concrete will move up this amount. So P time L concrete divided by area concrete E concrete. If the steel moved down and the concrete moved up, the two distances, if we add the two distances to each other, just distance, I don't care up or down. This distance plus this distance must equal the difference between the two material, 1.2 millimeter. So P, the length of steel 4,000, area of steel plus the force P time 4,000, the length of concrete divided by area concrete time E. I forget to figure out what is the area of steel and what is the area of concrete. Area of concrete is the area of the inside diameter of the inside circle, which is pi divide 4 time inner diameter 60 millimeter square. So pi divide 4 times 60 square. It will be 2,827.4. The area of steel will be the outer circle area minus the inner circle area. So it will be pi divide 4 times the outer 1 square minus the inner 1 square. One 1,021 millimeter square. So area of steel 1,021 time area E of steel 200 gigapascal. I'm gonna multiply it by 1000 to be megapascal. Area of concrete 2827.4. 2827.4 time E, Young's modulus of concrete is given 25 gigapascal. It will be 25,000. Will equal 1.2 millimeter. The only unknown in this equation is the applied force that I assumed. The applied force will be 15752.6 Newton or 15.75 kilonewton. Keep in your mind, this force is coming to push the steel down. So stress in steel will be the applied force 15.75 divided by the area of steel, which is 1021 negative. It will be, I can multiply it by 1000 one more time to be in Newton. Negative 15.4 megapascal. And stress in concrete, this force is coming to pull the concrete up. So it will be tension 15.75 kilonewton. I can multiply it by 1000 to be in Newton, divided by the area of concrete, which is 2827.4. So the stress will be tensile. How much? 5.57 megapascal. This is how to figure out the stresses in steel and the concrete in a composite column under change of temperature. It's a long story, but you have to understand it. First of all, I'm gonna assume each material will expand freely. So we will have a difference between the two materials. This difference cannot happen. So I will ask the steel to move down a little bit. I will ask the concrete to move up a little bit under the effect of the same force P. Why the same force? For summation F of Y equals 0. So it will be the same force. So the force P trying to push the steel down and the same force P trying to pull the concrete up. The two material will move under the effect of P equal the difference between the two material. So PLEA for steel plus PLEA for concrete will equal the difference between the two material. I can find out the force P. Once you get the force P, I can divide the force P by area concrete and the area steel to find out the stress. And keep in your mind, this force pushed the steel down, so it will cause compression. And the same force pulled the steel as a concrete up, so it will cause tension.